Hi guys, this video is going to be about action and reaction pairs, which is a part of Newton's third law. So let's look at what Newton's third law says. It says that for every action there's an equal and opposite reaction. So that explains why your hand hurts when you punch a wall. So here on the left we have a picture of a guy punching a wall. He's punching it pretty hard. And then this is what might happen to your hand if you punch a wall. It would probably hurt. But why does your hand hurt if you're hitting the wall? Because your hand is hitting the wall. Well, the reason your hand hurts is because the wall hits your hand back with the same force. That's what this means when it says for every action, there is an equal and opposite reaction. It's opposite because it's in the opposite direction, right? So the hand is hitting the wall in this direction. Let's imagine that the hand is hitting the wall with like 50 newtons or something, right? Remember, newtons is how we measure force. So we use centimeters or inches for length of something. We use newtons for force to measure how powerful a force is, right? So let's imagine the guy is punching the wall with 50 newtons of force. That means the wall hits his hand back also with 50 newtons of force. And so that's why it's an opposite reaction, because it's in the opposite direction. Notice these two arrows are opposite each other, but they are equal because they are the same amount of force. So that's why your hand would hurt if you punched a wall, right? That's why boxers wear boxing gloves, because they're doing lots of punching. They got to protect their hands from that force because of Newton's third law. So let's look at some more examples to really get this down. If you're skateboarding, for example, I just bought a skateboard this summer. I tried to learn how to skateboard. I was like slowly inching my way around the neighborhood. So when you're going forward on a skateboard, you're actually pushing backward with your foot on the ground. So notice this person's foot is pushing on the ground kind of at a diagonal, like down and backwards. And then the ground pushes back the opposite direction. And that's what makes the skateboard go forward, right? That's the reaction force. So let's imagine that you're pushing against the ground with, I don't know, maybe 65 newtons of force. Then the ground would push you back with 65 newtons of force, and that's how you're able to go forward. Same with hammering in a nail. The hammer is pushing down on the nail pushes back up on the hammer, right? That's why sometimes the hammer can like recoil. It doesn't always, but sometimes it does because of that reaction force. And then here's another example. Let's say someone's pushing on a brick wall, right? Let's imagine that they're pushing with like 115 newtons of force. Well, then they're also going to feel 115 newtons of force back because the wall is going to push them back just as hard, right? So that's Newton's third law, action and reaction. One more interesting thing I want to go over, I don't have a slide for this, but let's imagine you're driving in a car. I'm having issues drawing cars, but this kind of looks like a car. So let's imagine you're driving in a car, and here's your windshield on the front of the car. And let's say this little tiny bug hits your windshield. Let's say that it hits your windshield with, I don't know, maybe 10 newtons of force. Now the windshield is probably going to be fine. In fact, you probably have bugs splattered on your parents' windshield right now, and the windshield never cracks, right? Because it's not that much force. But the bug gets splattered and dies, right? Now why does the bug get hurt and the windshield is fine? Because we know we have the equal and opposite reaction that is also 10 newtons. So the windshield feels 10 newtons of force and the bug feels 10 newtons of force. So why is the bug dead, but the windshield doesn't even have a crack? Well, it comes down to the mass. The mass of the car is much bigger than the mass of the bug. And the car is also made of some stronger materials, right? Glass, they specially treat glass that they're going to put on windshields so that it can withstand some impacts, so it doesn't shatter every time a rock hits it, right? Well, bugs, they're soft and squishy, a lot of them, right? Not all of them, but a lot of them are kind of squishy. So it has a smaller mass, so it can't withstand the same force that a car windshield can, right? But there's always an equal and opposite reaction because that's what Newton's third law tells us. So hopefully that was helpful, and good luck on the test.